4.4 Graphs of sine and cosine, sinusoids. We're going to start this lesson by reviewing the values of the unit circle on the axes. Okay, so I'm going to draw the unit circle here, and if it's the unit circle, we know that this is the point 1, 0. We know that this is the point 0, 1. We know that this is the point negative 1, 0, and that this is the point 0, negative 1. We also know that the first value in that ordered pair is the cosine of whatever angle this is, right? And this is 0. This is pi over 2. If we're going in a counterclockwise direction, this is pi. This is 3 pi over 2, and then we're back to 2 pi. We could keep going. This would then be 5 pi over 2. This would then be 3 pi, because it'd be 6 pi over 2, which reduces to 3 pi. This would be 7 pi over 2. 4 pi. We could keep going in the counterclockwise direction. We could also keep start here at the positive x-axis, and we could go in the clockwise direction. And then this point right here would be the point negative pi over 2. And then if we kept going in the clockwise direction, this one right here would be negative pi. And then this one would be negative 3 pi over 2. And then this one would be negative 2 pi. So we know that that first term is the cosine of whatever that angle that we're talking about is. It could be the cosine of 0, and the second one then would be the sine of 0. Or we could look at it as the cosine of 2 pi, comma, the sine of 2 pi. Or we could look at it as the cosine of negative 2 pi, comma, the sine of negative 2 pi. So, the cosine of 0 is 1. The cosine of 2 pi is 1. The cosine of negative 2 pi is 1. The sine of 0 is 0. The sine of 2 pi is 0. And the sine of negative 2 pi is 0. So I think you can kind of understand what I'm saying, and I know that we've all done this previously, but just reminding you that if we were looking for the cosine of pi over 2 or the sine of pi over 2, we could draw this little unit circle and remember that this is pi over 2 right here, and that this is the point 0, 1, and then the sine of pi over 2 is 1. So I want you to be using that because we're going to be asking you to graph these without a calculator. So if you're graphing them without a calculator, you're not going to be able to ask the calculator what the cosine of negative pi is. You're going to have to remember that, negative pi coincides with this point right here, and so cosine would be negative 1. So now we're going to use that to make a chart and sketch the sine function. So I'm going to make my xy chart, and remember we're trying to graph y equals the sine of x, so that is my y. We're going to use 0, we're going to use pi over 2, pi, 3 pi over 2, 2 pi, and then we're going to go in the negative direction. Negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. And I think you guys were probably able to fit it on your paper. I fit it on my paper, but it's hard to draw small on this iPad. So now, at 0, we can see that the sine is 0. At pi over 2, your sine is 1. At pi, your sine is 0. At 3 pi over 2, your sine is negative 1. At 2 pi, you're back to 0. Now, if we were going in the negative pi over 2 direction, the sine of negative pi over 2 is negative 1. The sine of negative pi is 0. The sine of negative 3 pi over 2 is 1. And the sine of negative 2 pi is 0. So now we're going to plot those points, and we're going to look at the graph of the sine function. So we're going to make sure that we put these in. We've got pi over 2 pi, 3 pi over 2, and 2 pi. This one is negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. We're going from positive 1 to negative 1 on the y-axis. And now we plot our points. 0, 0, pi over 2, 1, pi 0, 3 pi over 2, negative 1, 2 pi 0, negative pi over 2, negative 1, negative pi 0, negative 3 pi over 2, positive 1, and negative 2 pi 0. And now we just want to draw a smooth curve through these points, and we have graphed the sine function. Sorry, I missed that one point there. Sorry about that. But we have graphed the sine function. So now we're going to use that same unit circle that I just talked about and that I just drew here, and we're going to make a chart for cosine. And so we are going to make our xy chart. This time we are graphing y equals the cosine of x. We're going to do 0, pi over 2, pi, 3 pi over 2, 2 pi. Then we're going to go to negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. Okay? So now on our unit circle, we see that the cosine of 0 is 1, cosine of pi over 2 is 0, cosine of pi, negative 1, cosine of 3 pi over 2, 0, cosine of 2 pi, 1. Then if we go in that clockwise direction, our cosine of negative pi over 2 is 0, cosine of negative pi, negative 1, cosine of negative 3 pi over 2, 0, and cosine of negative 2 pi, 1. So now on our cosine graph, we are going to put in and label all of our points. Pi over 2 pi, 3 pi over 2, 2 pi, negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. We go from positive 1 to negative 1 on the y-axis. And now we just plot our points. We start 0, 1, pi over 2, 0, pi, negative 1, 3 pi over 2, 0, and 2 pi, 1. Then we go negative pi over 2, we have 0, negative pi, we have negative 1, negative 3 pi over 2, we have 0, and negative 2 pi, we have 1 again. So now, again, a smooth curve connecting these points. And remember, they have to be rounded plump at the bottom. You cannot make them V's, okay? So please do not make it a V here where it goes down. That is an absolute value function, okay? So please do not draw that with a V. Make sure that it's nice and plump and round at the bottom. And now, I think we are good, and we're going to move on. And you guys had that last year, so that shouldn't have been too difficult. Just to, wanting to remind you, and for anybody that really, did forget and wanted to be reminded, that was a good little graphing episode there. All right, so now a function is a sinusoid if it can be written in the form f of x equals a times sine, it could be sine or cosine there, of bx plus c, and then plus d, where a, b, c, and d are constants, and neither a nor b is 0. Since cosine functions are themselves translations of sine functions, any transformation of a cosine function is also a sinusoid by the above definition. So, like I said, it could be sine or cosine. If you gave me a sine function, I could give it to you back as a cosine function that's been translated. If you give me a cosine function, I can give you back the exact same function as a sine function that's been translated. So it's sine or cosine there when they're asking you to draw a sinusoid. There's a special vocabulary used to describe some of our usual graphical transformations when we apply them to sinusoids. Horizontal stretches and shrinks affect the period and the frequency. Vertical stretches and shrink affect the amplitude. and horizontal translations bring about phase shifts. So all of these terms are associated with waves, and waves are quite naturally associated with sinusoids. So you might want to highlight this, because if you're going to, hopefully you won't, but you might forget that horizontal stretches and shrinks, they have to do with the period and the frequency. And then your vertical stretches and shrinks are going to be associated with your amplitude. And then you've got your horizontal translations have to do with your phase shift. So you're going to have to remember, because we're going to be finding the period and the frequency and the amplitude and the phase shift. And you're going to need to remember which one is associated with which. Okay, so here we go. The graphs of y equals a times the sine of b times the quantity x minus h plus k, and y equals a times the cosine of b times x minus h plus k, where a is not 0 and b is not 0, have the following characteristics. Now, I'd like you to notice that this is a little bit different than the one that I gave you a couple of pages beforehand. It was a sine of bx plus c plus d, okay? So what they ended up doing is they factored out the b, right? And then when they did that, this c divided by b became h, right? So, and they did it as h equals negative c over b. But your k and your d are the same thing, okay? So please be careful there, because c, if you notice, c went away. So if we, went to highlight these just to remind ourselves, what kind of functions we have here, our c went away, and that's the reasoning why, okay? So don't worry about the c. We're just going to use h and k here, and it'll be okay. But so now our amplitude is going to be the absolute value of a. So our amplitude can be positive or negative. Well, actually, it's always positive, but that number a could be positive or negative. And so it would just be a negative sine function or a positive sine function, depending on whether it's positive or negative. The amplitude's always positive. So if I asked you for the amplitude and there was a negative 2 there in front of that sign, your amplitude would still be positive 2, okay? Because it would be the absolute value of that negative 2, even though that negative might mean that you have a negative sine function. Graphically, the amplitude is half the height of the wave. The period is 2 pi divided by the absolute value of b. And graphically, the period is the length of one full cycle of the wave. And you can see where your b is. Your b is that number that's the coefficient of x. Okay, it's also, if there's another number there and you have to factor that b out, then that b is still going to be that is the part of your period. You're going to take 2 pi divided by the absolute value of that, and that's going to be your period. The frequency is the reciprocal of the period. So notice that you're just flipping those two, and it's the reciprocal of the period. It's the absolute value of b over 2 pi. So graphically, the frequency is the number of complete cycles the wave completes in a unit interval. I noticed we have a little mistake right here, but when compared to the graphs of y equals a sine bx and y equals a cosine bx respectively, they also have the following characteristics. A phase shift of h and a vertical translation of k. Okay, so that's where your hk comes in, and that is just taking your regular y equals the sine of x and y equals the cosine of x, and it is shifting it. All right, so now we're going to go to our first couple of examples here and find the period of y equals the sine of x over 2 and use the language of transformations to describe how the graph relates to y equals the sine of x. So what I'm going to do is I just thought, well, we could remember just so it will help us when we start doing more difficult ones, our y equals a times the sine of b times x minus h and then plus k. Okay, we're going to remember that. And we're going to remember that the number in front is our amplitude and that this b right here is our period coefficient. We call that the period coefficient because it's not the period. We have to calculate the period using this b. Let's remind ourselves that our h is our phase shift. And that would be whether it's shifting left or right. And our k is our vertical translation, which is meaning whether it's going up or down. Okay, so that is just a little reminder of what we just talked about. And now when we look at this, really 1/2 x is just our b, right? So our b there is 1/2. So by looking at that and comparing it to all the things that we have, our amplitude is 1, right? And our period coefficient, which is not our period, it's our period coefficient, is 1/2. Our phase shift is 0. We don't have a phase shift. And our vertical translation is 0, right? There's no vertical shift, so that means it's right on the x-axis. So let's take our period coefficient and let's calculate our period. And we said it was 2 pi divided by the absolute value of b. And so this is going to give us a period of 4 pi. And that means that it completes a full cycle in 4 pi radians. And so now they're asking us to use the language of transformations to describe how the graph relates. So we're going to say the graph y equals the sine of x over 2 is a horizontal stretch of y equals the sine of x by a factor of 2. Remember those horizontal shrinks and stretches? It's always the reciprocal, which is actually the factor. And also I want you to remember that the regular sine function, just sine of x, completes a cycle in 2 pi radians. So it starts at 0, it goes to its highest point, goes to 0, goes to its lowest point, and back to 0 in 2 pi radians. So what they're saying that this 1/2 is doing is, actually I'm going to erase this just so I can show you it using the same, like let's say that's 4 pi and this is our 2 pi. Well, it's about halfway. Anyway, pretend like that's halfway. So instead of completing it in that, it's going like this and it's completing it. Do you see how it's horizontally stretched? So that's what happens with when you have a period coefficient of 1/2. It is vertically stretching that graph, okay? All right, so the second part, find the amplitude of y equals, this time it's going to be 1/3 sine x, and use the language of transformations to describe how the graph relates to y equals the sine of x. So again, we're going to be using, this thing up here to remind us of what everything is. And we're going to say, okay, well, our amplitude, which this one's actually asking for, is going to be what's in front of the sine. So our amplitude is 1/3. Now, that was what they were asking, but since we're going to be, having to learn how to graph these, I'm going to go ahead and say, what is our period coefficient? And that would be the what's in front of this x, that'd be 1. And our phase shift is 0. And of course our vertical translation is 0. So it's not shifted up or down at all. If our period coefficient is 1, what would our period be? It's going to be 2 pi divided by the absolute value of 1. So our period is 2 pi. So when your period coefficient is 1, that means it's going to complete a cycle in the 2 pi radians, just like I showed you up here. That's completing a cycle in 2 pi radians. This has a period coefficient of 1, but a period of 2 pi. Okay? So now, using the language of transformations, we're going to describe how the graph relates to y equals the sine of x. So the graph of y equals 1/3 sine x is a vertical shrink of the graph y equals the sine of x by a factor of 1/3. So now, let's think about what that looks like, okay? So I have here my regular sine function. Like I said, it goes up and goes down. Oops. Well, this time I made my graph bigger. Sorry, guys. But let's pretend like that's, your regular sine function. And it's going from 1 to -1 here. That's your normal, okay? What we're saying for this one is that it's going to start and end, because it still starts and ends and completes a cycle in 2 pi radians. But if the amplitude is only 1/3, that means it's only going to 1/3 here and to -1/3 here. So right in the middle here, where I go up to 1, it's only going to go up to 1/3. And right here in the middle between pi and 2 pi, it's only going to go down to -1/3. So it looks like this. And so you can see how we said that was a vertical shrink, because it's like pushed down. So vertically it has been shrunk. Okay. On to our next example. Construct a sinusoid with period pi/3 and amplitude 4 that goes through the point 2, 0. So the first thing we need to deal with is our period. And if we know the period, we need to find out, because we're trying to construct a sinusoid, we need to know what the period coefficient is. So the first thing I'm going to do is find the period coefficient. Okay, so I know that our period is equal to 2 pi divided by the absolute value of b. Well, they're telling me that my period is pi/3. So that means that pi/3 is equal to 2 pi over the absolute value of b. So I'm going to go ahead and cross multiply. The absolute value of b times pi equals 6 pi. Then divide by pi. So the absolute value of b is 6. And my B's and my 6's look alike, so I apologize. But these are 6's over here. That's a 6, that's a 6. Okay. So that means that my B could be positive or negative 6. Okay. We are just going to choose positive 6. Okay. You could choose negative 6 if you wanted to. We're arbitrarily choosing B equals positive 6. Okay. The second thing we're going to do is we're going to find the amplitude. And really, they've given us the amplitude. So we're not actually finding amplitude. We're actually finding A. Because when they give us that the amplitude is 4, that means that the absolute value of A is 4. Your actual A could be plus or minus 4. And we're going to, again, arbitrarily choose A equals positive 4, okay? But please know that when they give you that amplitude of 4, amplitude is always positive. So you have to say, I'm going to choose, whichever one I'm going to choose. So now, because you really, because we're creating our own function here. So that's why it's just easier to choose a positive one. The third thing we're going to do when we're creating our own function, given what we've been given, we have to make sure the graph contains the point 2, 0. Okay, so the third thing we're going to do is make sure that it does. Because right now, we have our A and our B. Our A is 4, our B is 6. Okay, but what kind of shifting has to go on to make sure that it passes through 2, 0? Okay, so if right now you've got Y equals, you've got your A, and I put sine here. I always tend to go to sine first. And I'll go ahead and finish what I was going to do. Sine of, and then this would be 6 times x minus h, and then your plus k, okay? So that's what we have so far. We have our A and our B, okay? We don't really, right now, like the regular sine function would start at 0, 0, right? But since they're wanting us to start at 2, 0, why don't we just think that that is a shift to the right 2? So that's going to affect this. And we don't shift at all. So this is going to be 0, right? But that's going to be 2 units to the right, okay? Which is we're going to leave that negative, right? So that becomes y equals 4 times the sine. And by the way, and so that would be 0. By the way, the reason I chose sine is because I knew that that HK would be our 0, 0. And so, because you're on the cosine function, you're at your highest point, right? And you could have said, you could have done this differently. It could have been, there's infinitely many equations that you can write for this. We're trying to write the easiest one, okay? So think about the regular sine function going through like that. Now, this one did have an amplitude of 4, so look, I would have made that 4, and I would have made that negative 4, right? And it is completing a cycle in pi over 3 radians, okay? So that would be pi over 3 because that's your complete cycle, okay? So do you see how you can actually just take that little mini sine function and make it the one that you're talking about? And now what we're saying is, hey, if this was 0, 0, and we want it to pass through 2, 0, let's just shift it over. So if I took and I just shifted it over to, I don't know, this is going to be pi over 6, which is like a half. If I shifted it 2, I would be way down here with radians, if we were actually looking at our radians here. I don't know why this pencil is not working here. Come on. There we go. Because, well, I'd have to get my calculator out, but if you were actually shifting it to, this down here might be the 0.2 comma 0. You see what I'm saying? So what we're doing is we're shifting it 2 units over so that now it still is going to complete a cycle in pi over 3 radians. That means from here to here is still going to be pi over 3. But it's not going to be the, you know, this is going to be 2. And this is going to be, you know, something else. You know, 2 plus pi over 3. Whatever that is in radians. But we are shifting it to the right. Okay, whatever we've done right here, this is shifting it. This equation shifts to the right. All right, so now if we simplify that, y equals 4 sine of 6x minus 12. And this is your equation with that set of circumstances. Okay, so now, next example, constructing a sinusoid by transformations. Construct a sinusoid y equals f of x that rises from a minimum value of y equals 2 at x equals 0 to a maximum value of y equals 6 at x equals 6. So, first thing that we're going to do is we're going to figure out what the amplitude is. Okay? You're thinking y equals a times sine or cosine of b times x minus h plus k. So you're thinking of that. First thing you're thinking of is, hey, what is my amplitude? And so at x equals 0 is the minimum value of 2. Okay, so I'm over here just going to draw a little xy axis here. 1, 2, 3, 4, 5, 6. And the reason I went up to 6 is because it's going to a maximum of 6. So what we're going to do, I'm going to darken this one and darken this one. I want to find out what's halfway between. Look, 1, 2, and then 1, 2. So this one right here, this line right here, is halfway between. We call that our center line. And for this particular function, it's going to be 4, right? Because it's 2 away from 2, and it's 2 away from 6. So our center line is 4. This, it has an amplitude of, you can see it, 2. Because look, this is our amplitude of 2. This one is our amplitude of 2. So our amplitude is 2. And that is actually the absolute value of A, right? We don't know if it's going to be it's going to be a positive function or a negative function. So that is the absolute value. All right, the second thing we're going to do is we're going to find our period. And let's think about what our period is, or what the definition of a period is, okay? A full period, by definition, goes from min to max and back to min. Now this is for the sine function. For the cosine function, it would go from max to min back to max, okay? And also I'll put of sine x, or y equals sine x, goes from min to max and then back to min. So if I know that it rises from a min of 2 and then to a max of 6, and then back to a min of 2, and that's my full period, then this sinusoid goes from min to max in x equals 6 units. And if we went then back to min, that would be in another 6 units, giving us a total of 12 units that it completes a cycle in. I'll say that completes its cycle. So if it's completing a cycle in 12 units, that is its period. So the period of this sinusoid is 12. Okay, I wrote this out because I guess you guys could have replayed it, but I felt like we just had to talk about it. So one full period for the sine function goes from min to max and back to min. This sinusoid goes from min to max in x equals 6 units and then back to min in another 6 units, giving us a total of 12 units that completes its cycle, okay? So I've got our period of 12, and then remember, we need to find b. So we know that the 2 pi divided by the absolute value of b now is 12. So if I multiply by the absolute value of b on both sides and divide by 12 on both sides, my absolute value of b is pi over 6. So my period coefficient is pi over 6. Now, the third thing that we need to do before we create this sinusoid is we have to decide, do we want a sine or a cosine curve? Okay, the last one we chose sine because of the 2, 0. You know, it was easy to think about just shifting it. But this one, let's think about, because it starts out at 0 at its min. Okay, so it's starting out at its min here, and then it's going up to its max and back down, like we said, in 12 units. So its max was at 6. Okay, so this is what we have so far. Okay, and this, to me, since it's at its lowest point at 0, that tells me to use a negative cosine curve. So how do I make that cosine curve negative? Well, that's in the amplitude. So I'm going to choose my amplitude to be -2. Okay? We knew that it was, you know, rising and falling in 12 units, so we've calculated that our b is going to be pi over 6. And so we've got, you know, our negative cosine curve, so we know we're going to use cosine because it was at its lowest point at 0. So then that made it so that we didn't have to do a phase shift. If we wanted to start it here, you know, that would, so that we could have a positive cosine, a positive sine curve, we would have had to shift it, you know, phase shift it. Well, let's just start it here at 0, and we don't need a phase shift. So the fourth thing that we do is figure out, like, how do I, because, you know, typically our cosine would start at -2 here, you know, and that's if our center line is 0, but it's not starting at -2. It's starting at +2 as our lowest. So look at that center line. That is your vertical shift upward. So instead of having a center line of the x-axis, we have a center line of y equals 4. So that means our d is 4. Okay, so I put just since the sinusoid goes from y equals 2 to y equals 6, the center line is y equals 4. And thus, this sinusoid has a vertical shift of, up 4 units. So D equals 4. And again, you know, I'm talking about remembering this right here. You know, when I say D equals 4, I'm remembering that. And I guess, you know, K would be 4, actually, for that version of it, okay? So now, last thing we're going to do is write the equation of our sinusoid. Y equals -2 cosine pi over 6x plus 4. Okay, so that is our last example. I'm going to end this video now, but I'm going to go ahead and do another video with 2 more